This is the second part of the math proficiency test. You notice the menu on the left here. You don't only shows you the 13. There's actually 47 questions. And I'm not going to do all 47 in this video. I'll probably stop around the middle, around question 23 or something like that. So this is what it looks like to get to the first question. Do this. Now here's the calculator symbol, and of course the formula sheet here. If you click on that, this is what the calculator looks like that you get. It's just a normal, almost just an add, subtract, multiply, and divide. There is a percent button. There's actually a pi button. There's no brackets though. So you can't really do proper order of operations like you can in most calculators here. There's a square root, but it's really just mostly just like multiply, add numbers, that kind of thing. So it is fairly limited. So here's the first question, 5/3 minus 1 plus 2/3. So I'll put the question up there first. And in order to add, subtract fractions, you need a common denominator. Now these have the same denominator, but the minus 1 doesn't have a denominator of 3. Okay, so what we do is you think of that minus as being 1 over 1. And so what I'll do is I can get a denominator by multiplying it 3 top and bottom. So I am going to do that. I can actually just add these to make this a little simpler before I do that with the minus 1. So I can add 5/3 and 2/3, and they would add to 7/3. And so my minus 1 here, so you can think of this as being over 1. So if I multiply by 3 top and bottom, then I'll get, that's going to be, instead of minus 1, it's minus 3/3. So 7/3 minus 3/3 would be 4/3, which is this answer right here. See? Second one, the length of a classroom's 7.5 meters. Asked, what's the length in millimeters instead of meters? Well, 1 meter is 1,000 millimeters, or 100 centimeters, but we're doing millimeters here. So what I would do is for each of these 7.5 meters, there's 1,000 millimeters. So if we take our 7.5 meters and multiply it by 1,000, we'll convert it into millimeters. So that would be 7,500. So D is the correct answer for number 2. Number 3, Salim chooses a cell phone plan that charges a flat fee of $40 per month and then $10 per gigabyte of data. So it says, which equation represents the cost of Salim's cell phone plan? C is the cost, and N is the number of gigabytes used. So we've got 4 different choices here. Now, if you think about, okay, so the $40 is a fixed value, and the $10 is a variable. For every gigabyte, he's charged $10. So, for example, we wanted the cost, if you use 1 gigabyte of data, it would be 10 times the 1 plus the 40. If we wanted the cost of 2, it would be 10 times 2, because he's paying $10 for each of those 2 gigabytes of data he uses, plus 40. If he had 3, it would be 10 times 3. See, what I'm trying to model here is that this is the kind of expression that I'm using for the cost. It's 10 times the number of gigabytes used plus the fixed amount, 40. So that's the formula, D, for question number 3. We'll actually look at this a lot throughout these questions. Probably close to half these questions are from the grade 9 curriculum, and this certainly is. This is what we call slope y-intercept form, or y equals mx plus b form. That will come up in a lot of the questions. The 40 is the fixed or initial value, and the 10 is the variable cost or the rate of change. So number 4, Sam and Miko work different jobs. They're each paid an hourly rate with no base pay. So there's no fixed amount like this one. See, this has a fixed amount, those don't. Okay, most people are paid an hourly rate. Not always, but a lot of the time. So we're told that Sam earns $306 for working 15 hours, and Miko earns $189 for working 10 hours. So in order to figure which of these is correctly compares their pay, we should find out how much of them are each making per hour. So for Sam, he gets $306 for working 15 hours. So if we divide that, then we can see that he makes $20.40 per hour. So now I'm going to use this calculator a lot. I'll try to just do not take advantage of the functions that it has. Whoops, I'm going. 306 divided by 15. So there's the, now it's 2040. So the calculator doesn't put a 0 there because it doesn't need to. If I told it around 2 decimal places, it would. But 20.4 would mean $20.40. And Miko, his pay is 189. And actually, if you divide by 10, you're just moving the decimal one place. So that's why you get 18.9. So he's making $18.90 per hour. So let's check and see which one of these is correct. So A, it says Sam earns $19.80 more per hour than Miko. Well, not quite. He earns a bit more, but certainly not $19.80 more. This says even more. He makes $23.40 more. Well, that's certainly not true. The difference between this isn't even $2. So if they each work 5 hours, Sam earns $170 more than Miko. Well, he's going to make something more, so let's figure that out. So if we take Sam and multiply his $20.40 an hour by 5 hours, he gets $102. Now Miko, we would multiply $18.90 by 5, which is $94.50. Okay, is it 117 more? Certainly not. Okay, so if we, in fact, 102 minus 94.5, it's only $8 more. Whoop, I forgot my 0.5, 750, it'd be 750 more. Okay, so D's got to be the right answer. There's only one left. So if they work 30 hours, Sam makes $45 more than Miko. So we'll multiply Sam's wage by 30. So for Miko, we'll take his $18.90 and multiply by 30, and he gets $567. So we would take our calculator and go $612 and subtract $567. Okay, and so Sam does make $45 more than Miko. So D must be the correct answer. On the next page, we have question 5 here. And it tells us the temperatures at 2 a.m. and 4 a.m. are -8 and -2. And it says if the relationship between temperature and time is linear, which means it's going up or down the same amount each hour, what are the temperatures at the missing ones, the 3 a.m. and 5 a.m.? So if we look here, the difference from being -8 to -2 is that's gone up 6 degrees. And so then that means that, and that's 2 hours. So then every hour it must be going up 3. Okay, so to get this number here, we'll take our -8 and add 3, and then that would be -5. And so for the next one, it's gone up 3 again. So we take -2 and add 3, I'll get +1. So it's up to +1 now. So -5 and 1 are these two answers here. Now, you could also sketch a little thermometer to answer this too. Okay, so if you think of a thermometer here, so it starts here at -8, and once you get this going up 3, you could actually just count. See, that's going to be the temperature in the next hour, and then so at -5 first, and then see it goes to -2. That's the -2 you're given at 4 a.m. So there's a temperature here, and then of course it goes up 3, 1, 2, 3 more, so it's going to be +1 at 5 a.m. So that's another way you could answer this too. Question number 6, what's the value of this expression? And you have to remember bed mass for this. There's multiplication and 2 additions here. You have to do the multiplication first. It's like those skill testing questions they put on contests. If you have to follow bed mass in order to get the correct answer. So if we write out 2 plus 2 times 4 plus 2, I have to do the 2 times 4 first here. So 2 times 4 is 8. So I'm adding 8, 2, and 2. So 8 and 2 is 10. 2 more makes 12. So that's why the answer would be 12 here. Question number 7. Provincial Park offers 2 options for entrance fees, as shown in this graph. And so option 2 is a fixed $70, no matter how many times you visit it. But option 1 is there's an initial amount of $35, and then it goes up so much for every visit. So we're basically asked which of these statements is true. Which statement is true? So for 4 visits, option 2 is $15 cheaper than option 1. So let's look at the cost for 4 visits. 4 visits is right here. So for option 1, it costs $55. So right here, that'd be 55. Notice each block is 5. 10, 15, 20, like that. And of course, option 2 is the same $70 all the way along. So it says for 4 visits, option 2 is $15 cheaper. Well, option 2 is actually $15 more. So A is not correct. For fewer than 8 visits, option 2 is cheaper than option 1. And you see it now, 8 is right here. They're not the same at 8. They're actually the same at 7. So for fewer than 8 visits, mostly option 2 is actually more expensive. So B is not correct. For 11 visits, so 11 visits would be right here. So for 11 visits, option 1 for 11 visits costs 90. And of course, option 2 is the same 70 all the time. So for 11 visits, option 1 is $10 more expensive. No, it's $20 more expensive. So C is not correct. So D has to be the correct answer. And actually, for more than 7 visits, see, 7 visits is when they are the same. Option 1 for more than 7 visits, see, option 1 is more expensive than option 2. Or option 2 becomes the cheaper one once you get to 7 visits, or after 7 visits, I should say. Question number 8. For our 4 runners run a relay race, the time for each runner is shown. It says, how much lower is the total time of these 4 runners than the previous record of 240.201 seconds? So basically, in this relay race, these 4 people have run. So we need to find the sum of their times. So we would add all their times up, and it adds up to 235.659. And actually, let me show you what that looks like in our calculator here. Can I do? Yeah, there we go. So I would go 58.409 plus 59.685 plus 59.438 plus 58.127 equals, and that's the same 235.659.6 that I got there. Okay, so that's how you do that with the calculator. Now, how much lower is the total time than this record? Okay, so we're just finding the difference between the two of these. So we would take our calculator and subtract the 240.201 minus the time for the sum of all these runners. So 4.452. So A would be the correct answer for question 8. Question 9. 3 tables of values provide information about linear relations, but there's a 4th one. So you're asked really which one is not linear. Now, notice that the values in the left-hand side are going up by 1 each time. Okay, and as long as they're just going up by 1, all you have to do is compare the numbers in the right side. So from 5 to 7, that's going up by 2. From 7 to 9, it's also going up by 2. And 9 to 11, it's also going. So that's the characteristic of a linear relation. So this one's definitely linear. We're looking for the nonlinear one, where these are called the first differences, where they're not all the same. For B here, from 9 to 5, it's going down by 4. From 5 to 1, it's going down by 4. And 1 to -3 is also. So that's linear as well. They're all the same. Now, these ones are all 0. It doesn't change because this is called a constant relation, so it's also linear. So D has to be the correct answer here. And actually, if you look from -1 to 2, that's gone up 3. From 2 to 6 has gone up 4. From 6 to 11 has gone up. So the differences are different. So that's why that is the non-linear one. Question 10. We've got this shape, a trapezoid and a semicircle. And I'm going to actually enlarge it over here so it's easier to see what I'm drawing. And I'll make a couple of constructions here. And another one there. Now, the diameter of the semicircle is 6. So then this is also 6 from here to here. I'm drawing these up so this is perpendicular here. So that's 6 centimeters. So if the whole thing is 14, then this bit here and this bit here must be 8, because the difference between 14 and 6 is 8. So that means that this is 4, and this side over here is 4. So in this little triangle here, this is a right triangle, because that's supposed to be a right angle there. This side's 5, and this side's 4. Now, what I want to find is how big this H is here. And this is a right triangle, so I didn't do it in my PowerPoint, but there is a right angle right here. And so I'm going to find out how high that is, what the height is, because I need that for the trapezoid area formula. So we can use, it's called Pythagorean theorem. The sum of the squares of the two shorter sides equals the square of the longer side. So 8 squared plus 4 squared equals to 5 squared. Now 4 squared is 4 times 4, that's 16. 5 squared is 5 times 5, that's 25. I want to solve for h, so I want to get the h squared alone first. So the next thing I'm going to do is I'm going to subtract 16 from both sides. See, the 16 is added to the h squared. The opposite of adding 16 is to take away, so subtract 16 from both sides. So that adds to 0, and we're just left with h squared on the left. And 25 minus 16 is, of course, 9. And then, so to find what h is, we take the square root of 9, which is 3. So this side here is 3. So I can now find the area of my trapezoid. And again, let's see here. Here's the formula sheet. So that's the trapezoid area formula that is going to come up on the PowerPoint now. So there it is right there. And I wrote my formula with the h at the beginning. They have the h at the end. It's going to be the same thing. Okay, that doesn't change anything here. So I'll fill in my values. The height of the trapezoid is 3. 6 and 14 are the a and b. That's the length of the two parallel sides, the 6 and the 14. And so if we add 6 and 14, that's 20. So 3 times 20 divided by 2, so that would be 60 divided by 2 works out to be 30. And of course, you can use your calculator for that if you want. So that's the area of the whole trapezoid. Now, I need to find the area of this semicircle here. And for a circle, pi r squared is the area. So here's my area formula. Now I'm dividing it by 2 because it's only half the circle. It's a semicircle. So that's why the divided by 2 is there. So 6 is the diameter, so the radius, this would be 3 centimeters. So put 3 in place of my r. Now, if you evaluate that, you'll get 14.1. I'm going to actually bring my calculator over. Okay, see now. So it's pi, whoops, I want to clear. Pi times, now I can't do 3 squared, so I have to go times 3 times 3, is that, and then divide 2. Okay, so there's my 14.1 that I got. Okay, so let me do that one more time. Pi times is 2 squared, so times 2 times 2, and then divide, oh, sorry, it's 3, not 2. Let me clear that again. So pi, it was 3 squared times 3, and then divide the 2. Okay, there's the 14.1. So 14.1 is the area of the semicircle. Now, the shaded region or shaded area would be the area of the whole trapezoid minus the area of the semicircle. So I would subtract 14.1 from 30, which gives me 15.9. Now, notice 15.9 is not one of the listed answers. It says which is closest. They've actually rounded all answers to the nearest whole digit, whole number. So we would choose 16 because 16 is by far the closest answer to all those answers. Question number 11. Club has 30 members and 80% of the members attend a virtual event. The cost to attend the event is $10 per member. So what's the total cost paid by all the members attending the event, the virtual event? So we'd have to figure out how many people are attending. 80% of this club is attending. So we want to find 80% of 30. Now, to find 80% of a number, or any percent of a number, of means multiply. So we would go 0.8 times 30. 80% is 0.8 as a decimal. Now, just showing how the calculator works here. So you can actually, if you type in 80 and then hit the percent, see it changes that 0.8, 80% to 0.8 times 30. Okay, there's the 24 that we're going to get here in a moment. Okay, there's the 24. If I bring this back, you can also go 0.80 times 30 to get the 24. Okay, works both ways. Now, so with 24 people attend, it's $10 for each one. So we would go 24 times 10, which is $240. So that's why B is the correct answer for question number 11. Question number 12. What is the value of B in this equation? So let me write out the equation here. And I'm going to show you two different ways. I'm going to show you the algebra way, and I'm going to show you a numerical way, okay, a way you could answer. So two different answers for number 12 here, or strategies for solving this. So the algebra way is like if you were a grade 9 student, this is like a grade 9 question, how would you go about solving this? So the first thing I want to do is, because I have two different terms that have the variable b in them, I want them to be both on the same side. So I'm going to get my b terms, the variable terms, all on the left side. So this is a positive b here. Oh, sorry, I'm going to the right side. Sorry, not the left. I'm going to get them both the same side. So I'm going to take, now because the b over 4 is positive, I'm going to subtract b over 4 from both sides. Okay, and then, see, this is going to be 0 here on the left. And then this is going to be my b term once I simplify this. The b here is the same as b over 1. So to get a common denominator of this, if I multiply it by 4 top and bottom, like this, that's how this becomes 4b over 4. So I'm going to subtract this. 4b minus, there's actually a 1 here, 4b minus 1b would be 3b over 4. And so I've got my b terms collected together and simplified on the right side. Now, I want to get rid of this minus 12 because I want any numbers that don't have variables with them on the opposite side of where my variable term is. So subtracting 12, the opposite of subtracting 12 would be to add 12. So I'm going to add 12 to both sides. So I'm going to add 12 to the 0, add 12 to this. That's 0. Negative 12 plus 12 is 0. So I would just have 3b over 4 equals to 12. Now, I want to know what b is. This says 3/4 of b is 12. Okay, 3/4 of b is 12. So I'm going to multiply both sides by the reciprocal of 3/4, which is 4/3. And the reason for that is because these 4's will divide out, and so will these. So they'll just leave me b on my right side. And I'm multiplying 4/3 by 12 to find what b is. So the way I would multiply that is I could take my handy-dandy calculator and clear. So it's 4/3 times 12. There we go. So if I go 4 divided by 3, that's that decimal, times 12. Okay. So it's basically about 16. So I already had the answer for this, so I didn't do the transition for it. So 16 is the correct answer for that one. So we get b equals 16. Now, instead, I was going to show you another way to solve this. So you've got this equation, and you've got 4 possible answers. Let's say you didn't know the 16. So if you just check to see which one makes it a true statement instead of doing all the algebra, that will get you to the 16 as well. So, for example, if I were to clear my calculator, so just evaluate the left and right side. So I'm going to start at the 3. If I go 3 divided by 4, I get 0.75 on the left. And if I go put my 3 in place of 3 subtract 12 is negative 9. Notice that the value on the left and right side aren't the same. Actually, I have a calculator screenshot. 3 divided by 4 is 0.75. 3 take away 12 is minus 9. Okay, so that 3 is said not to satisfy the equation because it doesn't make both sides have the same value. Okay, now let's try the 8. 8 divided by 4. 8 divided by 4 is 2. Okay, and actually I'll put the screenshot up here. So there's the 2. And then on the right side, if I put 8 in place of b, 8 minus the 12 is negative 4. So 2 and negative 4, not the same number. Okay, so that doesn't work either. Okay, now we know the 16 is the right answer. So if I take my calculator and go 16 divided by 4, 16 divided by 4, see, it does work out to be 4 on the left. And if I put 16 here, 16 subtract 12, see, it does work out to the same 4. And of course, the last answer, 48, is not going to work. Here's my other screenshot here. If I put 48 divided by 4, see, is 12 on that side, but 48 here minus 12 is 36. So the left and right sides don't work out to the same value. So that's another way you could do that one. Probably a little shorter actually than the algebra method. Question 13. A right triangle has a hypotenuse of 73 centimeters and a base of 55. What's the height? So right triangle looks like this. And the hypotenuse is the side across from it's the longest side, the side across from the right angle. And it says the base is 55. And we're asked, what would the height be? Now, I draw this triangle down here just in case you were thinking, why don't we draw it like this? So you're told it's a right triangle, so it has to be a right angle. So it's not going to be like a scaling kind of shape as this one. So that's why I wouldn't draw it like this. Okay, so this is the kind of triangle. Now it could be flipped. It could instead, look like this. 73, 55. Okay, there's nothing wrong with that. But in fact, you could even draw it upside down like this. This is 73. This is 55. Okay, that would still be okay. There's nothing wrong with those either. Okay, so we go back to Pythagorean theorem like we did for an earlier question. So h squared plus 55 squared would equal 73 squared. If we take our calculator, 55 squared, we have to go 55 times 55, okay? And 73 squared, we'd have to go 73 times 73, to get those numbers, okay? So there's the 3025 and 5329. So I want to isolate for h squared, so I want to get rid of this 3025. So I would take that away from both sides. So that's gone. So we just have h squared on the left, and 5329 minus 3025. This is what we would do. Clear 5329 minus 3025. Okay, so 2304. That's the value that you get. There's the 2304. And then in order to solve for h, I'll take the square root of that. Okay, so the square root of that, so we would go square root of that is just 48. That's all you have. You actually, in this calculator, if you were just typing the 23, you'd actually do the 2304 first and then hit the square root. A lot of modern calculators, you would go square root and then type the number in, but it's the opposite for the one that you're provided with here. So 48 centimeters is the height, which would be this answer right here. So that's actually called a Pythagorean triple. So 48 squared plus 55 squared equals 73 squared. They're whole numbers that there's no decimals at all involved here. Just like I didn't mention the Pythagorean triple that earlier with the trapezoid, the 3, 4, 5 triangle. That was another Pythagorean triple. Question 14, which decimal number is equivalent to 2/5? So in the calculator, we would just go here, 2 divided by 5, numerator divided by denominator, see 0.4. So that's my answer for 14. Okay, that's a fairly short one. Question 15, 2 shrinking patterns are shown. Which numbers in both patterns? So you have to figure out how are they going down. Is there a common difference between them, a common divisor? And actually you'd have to play around with your calculator first. So for example, see if I go 36,864 minus 92,16. So the difference is 27,648. Well, the difference between those isn't 27,000. So maybe they're dividing by something. So if we go 36,864 divided by the next term, 92,16. Okay, so you get a nice whole number divided like that. That's a good sign. So it's 4. So if I do 92,16 divided by 2304. Okay, see, it's 4 again. So you're dividing by 4 there. This one here, 26244 divided by 8748. See, that was actually dividing by 3. And if I divided these, I would get 3 as well. So you have to do something like that. See, that's the division I showed for the first pattern. So if I keep on dividing by 4, if I take the 576 and divide it by 4, I get 144, so that's the next number. And if I take that and divide it by 4, I get 36, that's the next number. And divide by 4 again, get 9, that's the next number. So that's the next 3 numbers in the pattern A. So we're looking for the number that's in both patterns. So we would take the pattern B here, and once you figure out what it's dividing by, it's dividing by 3. I would take 972 and divide it by 3 to get 324. Divide that by 3 to get 108. Divide that by 3 to get 36. So the next 3 numbers in this one are 324, 108, 36, and actually be 12 next when you divide that by 3. So which numbers in both patterns? Well, the 36 is. So 36 is the correct answer for question 15. In question number 16, we're asked which representation has a rate of change of 7, and we're given an equation, a table of values, a scenario, and a graph. So 4 different representations. And so I've mentioned this before, but the equation y equals mx plus b, or the slope y-intercept form, is the topic here. And when you have an equation in that form, and that's what this one is, it's a variable equals a number times another variable plus or minus something. So this is in y equals mx plus b form. And so the rate of change is the coefficient of the x. That's the rate of change. So in this case, the rate of change would be 2. So that's why A is not our correct answer. If you look at the table, it's a little different from some of the earlier ones. Notice that the x's do not go up by 1. It goes 0, 7, 14. Okay, so they are going up by the same amount. Okay, but in order to figure the rate of change, it's not just the difference between these. We do need the difference between these. So rate of change is and delta, the triangle symbol stands for delta. Delta means the difference or change in. It's the change in y divided by the change in x, like from one line to the next. So the change in y, see, notice that's going up by 1. The change in x isn't going up by 1, it's actually going up by 7. So the rate of change would actually be 1 over 7. It's this change over this change. So the rate of change for this is actually just 1/7. It's not 7. So B is not a correct answer. Number C, the total cost to print t-shirts is made up of a setup fee of $65. So that's the initial amount. And a cost of $7 per t-shirt. Well, you see, that is the variable cost. That is the rate of change. So the rate of change, or the cost per shirt, is $7 per shirt. So this one is the correct answer. So the equation for this would be y equals 7x plus 65, because 65 is the initial or fixed cost, and the cost per shirt is the $7. So C is the correct answer. Now, if we look at D, just to sort of, show all the possibilities here. This one here, if I want to figure out the rate of change of the graph, then I'm going to make a bigger version of the graph here. So if we start at any point on the graph, for example, that point there, and if we go down, see, that's down 1, and actually notice they changed the scale here. Every block on the vertical axis is 1. See, that's 8, that's 7, 6, 5. But over here, it's a half. Okay, half. See, that it takes 2 blocks to make 1. So you have to really pay attention to the grid here. So we go down 1, you're actually going over 1 to another point on the graph. And see here, down 1, over 1 to another point. So the rate of change is the change in y, or the change here, and the change in x. So see, it's going down 1. This would be down 1 to the right 1. So the rate of change here would just be negative 1. So it's certainly not 7. Okay, so that's how you figure the rate of change for the graph. Question number 17, which fraction represents the shaded areas of the figure? So notice there's 4 blocks that are shaded, and altogether there's 2, 4, 6, 8, 10. If you count them, there's 12 blocks. So the fractions that's shaded is 4 of the 12. Now, remember, it's 4 out of the whole. You wouldn't go 4 to 8. Okay, there's 8 unshaded. If you're asked for the ratio of the shaded to unshaded, you go 4 to 8. But the fraction that is shaded is the fraction of the whole. Okay, so the whole thing's 12. Now, if you divide both 4 and 12 by 3, and actually, let me get my pen going here. So if we go to reduce the fraction, 4 divided by 3, sorry, that's not right. 4 divided by 4 to reduce this. I'm thinking of my 1/3. So 4 divided by 4 gives you this 1. Divide the denominator by the same thing, you get 3. Okay, so that's why 1/3 is the correct answer here. Question number 18. The table shows information about some students who walk to school. The number for the grade 6 students is missing. And the question is, which is closest to the percentage of students who walk to school and are in grade 6? So we're going to figure out this number. We know the total is 65. So to get the missing grade 6 students, we would take 6 the total and subtract the 18 and the 10. So if you do that, you get 37. So this number here should be 37. So we're asked really what's the percentage of the grade 6 students. So really what percent of 65, the total, is the 37. So to get the percent of something, we would take the grade 6 number divided by the total, and now this only gives you the decimal, and then we multiply it by 100% to change it into a percent. So 37 divided by the 65 total, and of course times 100. So if we bring our calculator back here, 37 divided by 65, okay, so 0.5. Now, you can't go percent because the percent actually divides by 100. So you have to go 37 divided by the 65, okay, so that's the decimal, and then times 100 to convert it into. That percent only converts a percent that's already percent into a decimal, okay? So 56.9, and of course that will round to 57. So 57% is the correct answer for question number 18. Number 19, Harjit's team raises $1,650 by selling 550 hockey pucks. Each puck sells for the same amount. If he collected 24, how many hockey pucks has she sold? So we got to figure out how many dollars she gets for selling each, or anybody in the team, for selling the hockey pucks. So we would take the total of the cost per puck would be the $1,650, and we'll divide that by the $550. So if you divide that, $1,650 divided by $550, so $3 per puck. And she sold 24, so you got to figure out what do you multiply 3 by to get 24. So that's a division question. So we go 24, what she got, divided by $3 per puck. So she actually must have sold 8 pucks. So 8 is the correct answer for question number 19. Number 20. Which of the following is closest, to the total surface area of this cylinder? So we've got a diameter of 8, a height of 25, and so surface area, so that's the second formula here. So here's a cylinder. So now we want surface area, so that's the surface area formula. That's the same one I'm going to use. So I call it SA for surface area. They call it area total. That's the same thing. So that's the formula. So here's my surface area. So 2 pi RH plus 2 pi R squared. Now, the diameter is 8, so the radius would be half of that. So we're going to put 4 here. The H is the length of the cylinder, so 25 is going to go here, and of course 4 here again. Now, when you do these, you have to be careful because if you're using this calculator here, you can't, like in my calculator, I can punch this all in one fell swoop. I can go 2 pi times 4 times 25 plus 2 pi times 4 squared. Okay, and I'm going to get the answer. But this calculator doesn't work like that. Okay, so this is how a lot of calculator students would have it work. So here, what you have to do, and actually, let me show the whole thing here. So I'd have to go 2 times pi times the 4 times 25, 4 times 25. Okay, so there's the 628.3. And then I'd have to, I can't go plus 2 times pi times 4 squared. I have to do this part separate. So I'm going to clear it, go 2 times pi. Notice I have to go times here. In my graphing calculator, I don't even have to multiply, put the multiplication symbol here, but you do have to use this one. Times 4 squared now, which means 4 times another 4. So there's the 100.5. So now we should be able to actually go plus 628.3, not have to clear that. Yeah, so there's the 728.8, the same answer I got over here. So 728.8, which is closest? Well, that's exactly the answer I got. So B is the correct answer for question 20. Question 21, on which number line, and notice it's the same fractions on each, are all the fractions placed correctly? All or both, there's only 2. So 7 quarters is 1 3/4. So 4 goes into 7 one time with 3 left over. See, 7 minus 4 is 3. And the other fraction is the 5 halves. So 5 halves, 2 goes into 5 twice with 1 left over, so it's 2 1/2. Calculators, you could also do this. 7 divided by 4 is 1 3/4, same as 1.75. 5 divided by 2 is 2 point. That's the same as 2.5. So you have to look for which number line are those in the correct spots. So start at the top one. See, notice it's got the numbers in quarters because there's 4 little ticks between 1 and 2. So these are all quarters. That would be 1 1/4, 1 2/4, 1 3/4. So that's actually correct there. And 5 halves is 2 1/2. See, 2 1/2 is right in the middle between 2 and 3. So A is the correct one. Okay. See, this one's wrong. 5 halves is 2 1/2. That should be over here. And see, that would actually be 2 1/4. This would be 1 1/4. Now, that one's actually in the right spot, but this is the one that's wrong for C. And see, that would be 1 1/4, not 7 quarters. And see, the 5 halves should be over here. Question number 22. The table of values represents the relationship between the cost C in dollars, the number of hours T to repair an electrical appliance. And you're asked, what's the hourly rate to repair this electrical appliance? So notice again, the time isn't going up by 1. It doesn't go 0, 1, 2, 3, etc. It goes in increments of 3, actually. So in order to get the rate of change, it's the change in the cost over the change in the time. So if we look at our table here, so now rate of change, hourly rate, that's the same thing. This is what the rate of change would be called in this context for this problem. So we would find the difference between the costs. So from 60 to 228, if you subtract them, you get 168. So that's my change in cost over the change in time. So from 0 to 3 hours is going up by 3 hours. So that's our time. So 168 divided by 3, okay, if we take our calculator here, 168 divided by 3, so 56. See, there's the answer right here, $56 per hour. That is the hourly rate. And I'm going to do one more question. We'll finish this one, then I'll stop this part of the video. This table shows the number of marbles in a bag by color. So there's 3 blue, 9 green, 6 red, and 12 yellow. And the question is, 1 marble is randomly selected from the bag. What is the probability of not selecting or not getting a yellow? Okay, so we want to know how many aren't yellow. So not yellow is the same as all the blue, green, and red added together. So we would add the 3, 9, and 6. And of course, that adds to 18. Now, we need the total as well. So we add all of them. There's 30. So the probability of not getting a yellow would be 18, because there's 18 non-yellow ones out of the 30. So 18 out of 30 is 0. Now, notice they've 0.6. Notice they've written them not as a percent, they've written them as a decimal. It's a very common way to write probabilities. So 0.6 is the correct answer here. And that's the end of the first, well, this is the second video, right? This is the first half, basically, of the calculator version of the math proficiency test.